Hi everyone, so the topic is resource allocation graph definition. So it is resource allocation graph. It consists of three terms: resource, allocation, and graph. So we are talking about the allocation of resources, and we are representing it using the graph. So this RAG or resource allocation graph is a graphical method to check whether our system is in safe state or not, and it checks that the system will be in the deadlock state or not after considering the request of processes for the resources and after allocation of the resources to the processes. And the short form which we'll be using is RAG, that is resource allocation graph. So let us now discuss the terminology which is related to RAG. Um, as you know that we are talking about a graph, so a graph consists of some vertices and some edges. So vertices in RAG are of two types: process and resource. And symbol for a process vertex is used as a circle. Like in this example, and this is representing some process P1, and the other vertex which is used in this graph is the resource vertex, and symbol for this is this rectangle. Like in this example, this is some resource which is R1. So this R1 box does not have any circle in it or any dot, so it is representing one instance or single instance resource. While in these two examples, this resource is having two instances and this resource is having three instances. For example, say we have two printers installed in our system, so that will be the two instances of the resource. So this is a single instance resource. This diagram depicts single instance resource, and these diagrams are two instance resource and three instances resource respectively. So vertex process and vertex resource. So two types of vertices are there in this resource allocation graph. Now let us talk about the edges. We have two types of edges: request edge and the assignment edge. Request edge is depicted as the directed arrow which is from process directed towards the resource. So that means process P1 is requesting for the resource R1. Likewise, the assignment edge is directed arrow from a resource towards a process. As in this example, this resource 1 has been assigned to process P1. So using these symbols and this terminology, we'll be creating a resource allocation graph. See, in this diagram, we have two processes P1 and P2 and two resources R1 and R2. And these are the directed arrows which clearly shows that this resource has been assigned to P1 as the direction of arrow is towards the process, and this resource this process is requesting for as this direction of the arrow is towards the resource. Likewise, R2 is assigned to P2 and P2 is requesting for R1, and both these boxes for R1 and R2, these do not have any circle or some dot, so that means these are single instance resources. This diagram, this is the same diagram, but there is some change. That is, this R2 box contains these two some circles. So these circles represents the instances of this R2 resource. So this diagram shows the multiple instance resources. Now we have talked about the terminology used in this resource allocation graph. So let's now see how these RAG check for the system state. So first step is to see whether our graph is single instance resource graph or multiple instance resource graph. Just see in this example, it is single resource instance. Step is to check whether there is a cycle in this or there is no cycle in this. If there is a cycle, then it it shows that there will be a deadlock for sure, and if there is no cycle, then the system is in the safe state. Like in this example, it forms a cycle. These processes are dependent on each other, so deadlock will surely be there. Our next example, now in this graph we have resource 2 with multiple instances. So this graph is multiple instance resource graph. So again, second step is to check for a cycle and if no cycle. But there is a change here. In multiple instance resource graph, if cycle is there, then we cannot say that deadlock will surely be there. Deadlock may or may not be there. But if no cycle is there, then surely system is in the safe state. So how to check now? If there is a cycle, how to check for a deadlock? Then again we have to apply the banker's algorithm. So if cycle is there in multiple instance resource graph, we will see using banker's algorithm that our system is in the safe state or not. We cannot say directly that system is in the deadlock state. So let's see some examples now. For example, in this graph, let's check it is single resource or multiple resource instance graph. So it is clearly showing here no more instances are given, so it is single resource graph. And second step is to check for the cycle. It clearly shows that there is no cycle in it, so we can say there will not be any deadlock if we allocate the resources in this manner to these processes. Second example. In this example, it is a multiple instance resource graph, mm, and also there is a cycle. But we are not sure that deadlock may or may not be there. So using Banker's algorithm, we will confirm that deadlock is there or not. We'll make allocation matrix and need matrix based on this diagram and solve using Banker's algorithm. So there is a cycle, but we are not sure. So there is a note here. Let's read it. It says, in case of resource allocation graph with multiple instance resources type, the cycle is a necessary condition for deadlock but not sufficient. It means every cycle in a multiple instance resource type graph is not a deadlock. How can we say that? Let's see. As resource 2 is having two instances, one instance has been assigned to P2 and other instance has been assigned to P3. So when P3 will release this instance can be allocated to process P2. So there is a cycle in first turn, but when this resource has been released by P3, this can be allocated to P2, then there will not be any deadlock. So this cycle is not a sufficient condition for multiple instance resource graphs. We are not sure whether the deadlock will be there or not. We have to check using Banker's algorithm. Like in this example, this P3 is also dependent on R1. So cycle is there in this graph and it is also multiple instance resource graph, so we can clearly say that it is having deadlock in the system. In the previous example, this P3 was not dependent on any of the resources, but now in this example this P3 is also dependent on R1. So this allocation cannot be done in any case, so deadlock will be there. Is that it is a graphical method to check whether a system is in safe state or not. So I hope you have understood this topic, and these are some terms which are related to this RAG, and we have already covered these. This is a process, resource, vertex, edge, request edge, assignment edge, single instance resource, multiple instance resource, cycle, deadlock. Please revise all your topics. Thank you.